it's possible for somebody to poison the ARP cache of devices within your network. And how can they do that? Well, they can send gratuitous ARP messages, simply saying, hey, based on this IP address, this is the MAC address you want to use. So why would they do that? Well, let's say this malicious user is sending out a gratuitous ARP stating that the IP address of 10.1.1.1, which happens to be the default gateway's IP address, is the malicious user's MAC address. What is that going to do to all the other clients in the network? Well, all the other clients in the network are now going to point to that malicious user as the default gateway based on the layer 2 MAC address. So all frames go to the malicious user, they capture all the frames, and then they forward those frames on. Now, how could you identify this issue? You could identify this issue by monitoring the traffic in your network using specialized tools, capturing traffic, using span and rspan. All of those can come into play while you are trying to analyze this traffic that's flowing through the network. And you'll see a pattern whereby traffic is not going directly to the default gateway when it should. It's being routed to, or not routed, but forwarded to another portion of the local area network and then being sent to the default gateway. So in this case, we have that gratuitous ARP, which is poisoning the ARP cache of all the clients within our network. So we can prevent this from happening by using dynamic ARP inspection. So dynamic ARP inspection goes hand in hand with DHCP snooping. So if you're troubleshooting dynamic ARP inspection issues, you need to have a solid understanding of DHCP snooping. So what happens with DHCP snooping is a binding table is created, and that binding table is going to show an IP address and a MAC address for a particular port. If we examine ASW1, we can look at the binding table by typing in show IP DHCP snooping. Pardon me, show IP DHCP snooping binding, and we'll see this binding table that was created here. So out fast Ethernet 0/1, you can see that PC1 has the address 10.1.1.10 and the MAC address 06D6. So it's going to make ASW1 is going to make sure that PC1 never has the ability to say, hey, if you want to reach 10.1.1.1, use 06D6. No, that's not going to happen because ASW1 sees that that type of ARP message can't come from this interface or come inbound on that interface because the IP address out that interface is 10.1.1.10. So the only type of ARP messages that can be sent are the ones that state, hey, if you want to get to 10.1.1.10, use 06D6. Those are the only ones that'll be accepted inbound on fast Ethernet 0/1. So this binding table is created by DHCP snooping. So DHCP snooping has to be enabled globally, and it has to be enabled for the correct VLANs in order to create this binding table. And then after that, we need to make sure that IP ARP inspection has been enabled correctly for the VLAN as well as enabled on an interface by interface basis. So we can look at the output of show IP ARP inspection VLAN to verify it's been enabled for the VLAN, and we can look at the output of show IP ARP inspection interfaces to make sure that the interfaces that need to be trusted interfaces have been enabled as such. So why trusted interfaces? Well, the trusted interfaces are simply going to allow any type of ARP messages in. It's the untrusted interfaces that are going to be analyzed. So every time an ARP request comes in that untrusted interface, it's analyzed. Is it legitimate? Is it the right IP address? Is it the right MAC address? And if so, it will be allowed through. If not, then it's going to be dropped. So let's look at the output of show IP ARP inspection here. Show IP ARP inspection. And we'll take a look at VLAN in this case. VLAN 10. We'll see that we have enabled IP ARP inspection or dynamic ARP inspection for VLAN 10. It's active and operational. If we want to look at our interfaces, which interfaces have been set as trusted and which ones have been set untrusted? Well, everything is untrusted by default, as you can see. Every single interface. And then if we analyze gigabit 0/1, we made them trusted interfaces because those are the ones that are upstream from the clients going up to our distribution layer switches. So let's examine now the configuration of gigabit 0/1. Show run interface gigabit 0/1. We'll see right here the command was IP ARP inspection trust to make that a trusted interface. So in this case, every single ARP message that's received on a trusted interface is just simply going to be uninspected. It's going to be allowed through. Whereas all the other interfaces, they're going to be analyzed to make sure that they match the entries in the DHCP binding, or pardon me, the DHCP snooping binding table. And we'll also take a look at show run pipe to include ARP. And we'll see here that the command IP ARP inspection VLAN 10 was utilized to enable dynamic ARP inspection for VLAN 10. So when you're troubleshooting issues related to ARP inspection, number one, make sure DHCP snooping is up and operational first. And then after that, once that binding table is created, double check to make sure that you enabled ARP inspection for that VLAN. And number two, you made sure that the appropriate interfaces were configured as trusted. You definitely do not want, for example, PC1 or PC2's interface or P3's interface to be configured as trusted in this case, because we're trying to prevent those devices from poisoning the ARP cache of other devices.